Hello guys, today we have to discuss about the tetracycline, the definition of tetracycline, introduction, classification, historical background, source, chemistry, SARs of tetracycline, mechanism of action, spectrum activity, uses and side effect of tetracycline. Tetracycline are octahydroneptane derivative, which are bacteriostatic in nature, and they are broad-spectrum antibiotics that kill certain infection-causing microorganisms and used to treat wide variety of infection. If we split the tetracycline name, there are four words: tetra mean four, cycle mean hydrocarbon ring, and ene mean derivation. So tetracycline contain four hydrocarbon rings and from which other chemical substances or drug are derived. Tetracycline are introduced 50 years ago as a potent and broad spectrum antibiotics. They are biosynthesized from acetic acid and propionic acid unit in microorganisms. Tetracycline possesses a wide spectrum activity against the gram-positive as well as the gram-negative bacteria. They are mainly designed for oral route of administration, but parenteral and topical form are also available. Now come to the classification of tetracycline. According to the duration of action, tetracycline are classified into three classes. The first one is the short-acting tetracycline. They contain the tetracycline, oxytetracycline, and chlortetracycline. Another one is the intermediate acting tetracycline. They containing two drugs, demeclocycline and metacycline, and their half-life is 12 hours. The last one is the long-acting tetracycline. Their half-life is 16 hours or more than 16 hours. They contain the doxycycline, minocycline, and tigracycline. Their classification according to the source from which the tetracycline are derived. There is two sources: natural occurring and semi-synthetic. In natural occurring, tetracycline, chlortetracycline, oxytetracycline, and demeclocycline. And semi-synthetic, there are doxycycline, meclocycline, metacycline, and minocycline. Natural occurring tetracycline are obtained from the microorganisms such as tetracycline are obtained from the various species of Streptomyces bacteria by fermentation technology, and chlortetracycline from the Streptomyces erupescens, oxytetracycline from the Streptomyces remosus. The stereochemistry of tetracycline is very complicated because the metacycline, oxytetracycline, meclocycline, doxycycline possess 5-hydroxy substituent having 6 chiral carbon atom, and other tetracycline have only 5 chiral carbon atom. The structure of various tetracycline are given such as they are different from each other on the basis of the chiral carbon atom: tetracycline, chlorotetracycline, oxytetracycline, demeclocycline, metacycline, meclocycline, minocycline, doxycycline, and tetracycline. The structure-activity relationship of tetracycline is on the basis of different groups attached to the pore ring. On position 1, there is oxygen attached. On position 2, if there is nitrile group, then the structure activity of the tetracycline is increased 20 times. On position 3 and 2, the key to enol tautomerism between the carbon 2 and carbon 3 are very important for the biological activity of tetracycline. On position 3, there is hydroxy group. If the hydroxy group is modified, then the structure activity of the tetracycline will be lost. On position 4, epimerization at carbon 4 and dehydration at carbon 5A result loss of structure activity. On position 5, substitution with hydroxy produce water soluble derivative which can be administered orally. On position 6, CH2 increase the antibacterial activity, and if there is elimination of 6-hydroxy group increase lipophilicity and more stable to acid. Example, doxycycline. On position 7, if there is amino group it increases the structure activity of the tetracycline. Electron donating group, electron withdrawing group at carbon 7 increase the antibacterial activity. D ring should be always aromatic. Change in this ring lead to the biological inactivation of the molecule. So this ring is very important for the biological activities of the tetracycline. Additionally, glycyl amino substitution at carbon 9 position lead to the new class of antibiotics such as tetracycline. So if there is any modification at carbon 1, there will be no bacterial activities. If there is modification or acetyl group attached to the carbon 2, slightly activity is retained. If any modification at carbon 3, no bacterial activities will be found. If alpha dimethyl amino group is attached to the carbon 4, so the activities of the tetracycline will be retained. If hydrogen is lost from the carbon 5A, there is inactive degradation product will be produced. The removal of hydroxyl methyl or both group from the carbon 6, more stable compound will be formed. If there are chloride, bromide, nitrite or dimethyl group is attached to the carbon 7, the activity of the tetracycline will be retained. A little information is available at the if chloride or methyl group if chloride or methyl group is attached to the carbon 9, the activities of the tetracycline will be decreased. If there is any modification at the carbon 10, 11, 11A and 12, the structure activity of the tetracycline will be completely diminished. So this was all about the structure activity of the tetracycline. Next time we will discuss about the biological uses or therapeutic uses of tetracycline, their side effect and contraindication.